Hello everyone. In previous session we have created a model from the scratch for the IDs detection and its classifications. But in today's topic we are going to detect the same IDs using the transfer learning concepts. And generally the transfer learning is a machine learning technique where a pre-trained model is adapted for a new but related task. Instead of training a model from scratch, transfer learning leverages the knowledge from an existing model trained on a large dataset and fine-tunes it for a specific task with a smaller datasets. And this approach is widely used in deep learning, especially for tasks like image recognition using model like ResNet 50 or BG16 or BG19. And transfer learning generally helps to reduce the training time and improve the performance and acquire less data for effective learning. And this ResNet 50 is also known as residual network, and it is a deep convolution neural network with 50 layers designed to address the vanishing gradient problem in deep networks by using the skip connection. It was introduced by Microsoft Research in 2015 as part of the ResNet family. And this dataset, this model ResNet 50 was originally trained on the image datasets, which is a large-scale dataset used for the image classification and object detection problem. And this dataset contained 14 million labeled images with 1000 different object classes. So this is very robust model for the feature extractions. Therefore, we are going to use this model in today's IDG prediction and its classification problems. Firstly, the first step is to acquire the datasets, and I have downloaded these datasets. I will provide the link of this dataset in the description part. And once this dataset is downloaded, I have stored it in my Google Drive. Then afterwards a pre-processing step arises, and in pre-processing step we read the RGB images and reduce its dimension to 128 cross 128 cross 3, where 128 cross 128 are the height and the width of the images, and 3 represents its color channel. Since it is a color image, its value is 3. And next, for the faster processing, we normalizing the each pixel intensity of the image in the range 0 to 1 by dividing it with 256, because the maximum possible value of our image pixel is 256. Next, for the smooth training, we are converting these data sets into the NumPy form, and then afterwards we visualize that our data sets in the pie chart and the bar chart. And once this pre-processing stage is finished, the model training stage begins. And in model training part, we have a ResNet 50 model and another sequential models. Generally, here we are using the two models. The first model is ResNet 50, whose function is to learn the features from the incoming images. And once these features are extracted, we pass these features to our another sequential model that we have created from the scratch. And in this sequential model, we can say that we are fine tuning our ResNet 50 on our this system datasets. And once these image features are passed to the sequential model, this model will learn the patterns of these features. And once this model training is finished, the model testing begins. And in model testing, we pass the test images to our models, and which will ultimately classify into the different category of the IDGs. And here I will show you the datasets. Datasets by here. This is the my datasets that I have downloaded. I have downloaded it from this websites. I think this is 2.13 GB augmented data size, and this is the original one 1.54. I have downloaded this augmented data sets 2.13. I'll provide this link in the description parts. And okay, I was showing the images, ID datasets. This is the IDGs There are 10 different category of the eye disease. This is the first category or first class of the eye disease known as central serous disease disease. And you can see here, this kind of eye disease will have the images similar to this. Similarly, I also have another disease eye classes, diabetics. Diabetics will have this type of the images. It has total 3,315 images are there. And next is the disc edema. Disc edema has 762 images, very less images there. It means it is a very highly imbalanced data set, is it? So on this type of the data sets, achieving the performance is extremely very hard, because this is a very imbalanced data set. Here is only 762 images, but in some diseases, in some folder there are more than 300 images. These are the images that are present in this dataset. Similarly, this contains the healthy eye. Yeah, we also have the healthy eye images. These are the samples of the healthy eye images. Now let's go to the coding part. Here, the first code is used to mount the drive, and this part of the code is used to check whether I'm using the GPU or not. Since I'm using the GPU, it is displaying I'm using the Tesla T4 GPU. Next is the data preprocessing stage. In data preprocessing stage, I have specified the location of my disease dataset. You can see here, it is in the research folder, and in research folder, it is I datasets. I copied this copy path, and I have pasted here. You can also paste here. Now afterwards, the next code is reading the images. I'm reading only the images that have the extension this category: JPG, JPEG, PNG, BMP, and GIF. And altogether there are 16,252 images are there. Next, in the next line of the code, since these images are in very less amount, so I am performing the data augmentation, due to which my training sample will get increased. And in data augmentation, I'm using this rotation range, wide shift range. These are the some of the data augmentation technique that I have applied to increase my data set sample, so that I will not face the model unfitting problem. Next, here this line of the code is used to read the data sets from my images. For example, I am just opening the image here and resizing it to this dimension. I am converting it into the array form and adding these images in a list called images. Here is the list and list labels, and I am also appending the labels of each images. Next, after that, I am performing here data augmentation. My augmentation is this data gen, and here is also the data augmentation data gen. I am using the data augmentation to each images that I have read. Next is I am saving these images to my Google Drive, so that later on I can read these images. And this line of the code is used to read the images. Since I have already read the images, so I am just commenting it. Now this code is used to load the dataset that I have already fetched in this code. Next, once images are loaded, now my training sample has been increased from 16,000 to 32,000, and label are also 32,000, and it contains the 10 different category of the classes, 10 different category of the diseases on the eye sample. And this line of the code is used to plot the images for the visualization purpose. I am here visualizing the images as well as their labels, and you can see here I am displaying the 5 images of each class here. These are the 5 different samples of the eye disease, and here are its corresponding label. This is disc edema, this is glaucoma, this is healthy eye, this is retinitis pigmentosa. I am just displaying the randomly the 10 images, where one image belongs to one class. Next, once this image has visualized, I am just plotting this pie chart, plt.py. From this code, I am plotting the distributions of these data sets. Now, for instance, this healthy eye contains 16.5 percentage of images out of the total 100 percentage of the images. And similarly, next visualization is bar chart. I am also plotting my bar chart in my code, and I am. You can see here I have plotted different category of my IDGJ datasets. For instance, this glaucoma is there, about 5800 images are there, and this contains 52,000 of the images. This is the healthy eye. Similarly, myopia contains, I think, 4500 of the images. This is the visualization of the distribution of the dataset, this IDG datasets. And similarly, next is, since I don't have the testing samples, so what I am doing here is I am splitting my images and labels to training set and test set, because I have only got the training sample is there, and here is no test sample is there. So I am splitting these images into train set and test set, and these total images are split into training set and test set, and these are its corresponding label. And next stage is model building stage, and in this model building stage I have imported this ResNet 50, and this has been trained on the ImageNet datasets, and I'm using this ResNet 50 in my. Here, yeah, I have said the weights. This actually, generally, basically, this testnet has been trained in these ImageNet datasets, which is about millions of images are there. So, I'm using the weights of this ResNet ImageNet, in which it has been trained. And here, I've include top equal to false. It means I am removing the fully connected layer, which generally outputs 1000 classes for the ImageNet datasets. I'm just removing that fully connected layers. Next is I have specified the input shape to this ImageNet dataset should be 128 cross 128, dimension, height, and width, and this tree it should be RGB image, and I have named this as a base model. And after that, I specified the base. I have freezes these layers of this base model. I have said base model trainable equal to false. It means this base model will not be used for the training, and it will be only used for the feature extraction. Therefore, I am extracting here features, and I have mentioned here out input should be the base model input. This is the input shape size, and output should be the base model dot con block, con 5 block, relu to relu, and this is the up to this layers. I am extracting only the ResNet 50 up to this layer. Generally, this ResNet 50 is very deep in size, but since I am only using it for feature extraction, so I am specifying that I only needed the ResNet 50 from top layer to conv 5 block to relu. Here it is conv block, this conv 5 block 3 is here, conv 5 block 3, you can see here conv 5 block yeah, it's up to here, conv block 5 relu 3. If you want to extract only the features of this layer, let us consider if you want to extract the features up to this layer, then you can just simply copy this and you can paste here. If you want to extract the feature up to the intermediate layer, you can simply paste here. But I don't want up to this intermediate layers, because extracting the features up to the intermediate layer is not a good concept. So I'll go a bit deeper. So I will remove this and let it be the previous one. This one up to here, up this layer I want my ResNet 50, and afterwards I'm extracting the feature extractor I have used. It is this part will use the ResNet 50 to extract the features up to this block. Then next is feature extractor dot output shape. I'm checking its shape. What is its shape? It will the output of this will be, I think, let's see here. Its output will be up to this layer. The output will be 44512. This is the this much output will be generated. 44512. I think this one is 44512 up to here. I am fetching the ResNet 50, and its output will be, output of this will be 4 cross 4. It means the size of the feature maps generated will be 4 cross 400, 4 cross 4, and it is feature channel or feature number. It means 512 features are present in each pixel of this 4 cross 4 feature map. Next, this is the summary of this feature extractor. You can see here, this one I have shown you already. This is the part of the ResNet that I am using. Next, afterwards, this will be used for the feature extraction, this ResNet 50, and according to this figure, now this figure here, the images feature will be extracted by this ResNet 50, and next I have to create this model, sequential model. So I am creating this sequential model. Whatever the input I am receiving, it will first pattern it, then day 256. After that, I'm dropping the 30% of the neurons, and since I have contained the 10 different category of the DJs, I am using the dense layer equal to 10, and for multi-classification problem I am using the softmax activation functions. And the summary of this classifier, this is the classifier here. This model is classifier, so its summary is generated here. This model name is classifier, and I'm generating this classifier here. It's say this is classifier, and here every parameter will be used for the training. But in case of this ResNet 50, we are not going to train them, therefore they are unknown. Trainable parameter is equal to this total parameters. You can see here trainable parameter is 0, because we are not training ResNet 50, but here this model we are training, so here the trainable parameter is equal to the total parameters. Next, after that, from this ResNet 50, we are extracting the features and pass this feature to our sequential model. Now I am doing the same thing. I am extracting the features. This is my training samples. I am passing my training sample to this feature extractor, which is the ResNet 50, and I have extracted the training features, and I use these training features to train my another sequential model. It means I'm using the two models. I'm not creating an end-to-end model, but I am just first extracting the features from this ResNet 50. After that, once the features are extracted, I am passing that feature to my another sequential model that I created from the scratch. And this code can be used to save the trained features and use later on. Next, what I am doing here is I am just training my classifier, my sequential model, using the Adam optimizer, and this learning rate is this one, and this is the loss function that I have used. Now you can see here the extracted feature name is train features. Now I am passing these train features to my classifier to train on these features, and I am passing this label base size is set to 32. Now this model is trained for the 50 books. I am splitting the validation to 0.1. It means 9:1 ratio. Out of the total train features, 90% of the sample will be used for training, and remaining 10% will be used for the validation. And this model has been trained for 50 books. You can see here in 40 books I am achieving a very good accuracy, because ResNet 50 is a very good model which has a very good ability to extract the features. So you can see that very good accuracy we are achieving in only in first epochs, but as the epochs reaches up to the 50, I think our accuracy is near about 96%, and this is the very good accuracy, training accuracy. Now once this model is trained, the testing phase begins. Here Now from these features our this model has been trained, and we will be using this model to for the testing part and the classification of the different category of the images. Now in this code, here is again saving and loading of the models, and after that this is my test images, and from again this test images I am using this classifier ResNet 50. I am using this ResNet 50 to extract the features. These features are extracted. Then after that I will pass this feature to my classifier or to my sequential model. Now this feature has been extracted using ResNet 50. I am passing these features to my classifier and checking the its test accuracy. We have achieved the 72% of the accuracy, which is quite good. Since I have not performed too much argumentation. If you can increase the argumentation and this training pokes and change the hyperparameters like filter size, kernel size, and learning rate and loss function, you can achieve the better accuracy. But since it is only for the testing purpose, I have not updated the hyperparameters here. But if you change the hyperparameters, you will achieve the better accuracy here. Now this is the we are predicting here y prediction. This is for the prediction generating the y true value. Next, this code is used to plot the confusion matrix. I have plotted this confusion matrix here. Next, this part of the code is used to plot the training accuracy and the validation accuracy. Now you can see here our training accuracy is extremely increasing very nicely. So it is a robust model, and this code is used to plot my output. I am plotting the 5 images of each classes at a time. So this code is used to randomly plot the 5 results of each classes. So I have switched from each class I have to display 5 images, and altogether there should be the 5 column. And you can see here. Let's see. See here, you can see the accuracy. This one. It is predicting it. This one. This is the retinopathy. It is also predict the retinopathy. You can see here the accuracy, but here we have been missed to recognize this image. So this is one of the limitation. But here we are achieving we are detecting correctly. Here also we detecting correctly, but we missed here. We detected correctly. We detected here correctly. Here again the correct prediction is performed, but again we missed here. Therefore our approach has only 72% accuracy. But as previously said, if you will update the hyperparameters, if you increase your data samples and use some regularizations and make your model some deeper, you may achieve the better accuracy. But still this accuracy is still awesome. You can see results. Now here in this code SVM classifier, similarly you can also perform use SVM classifier. For example, extracting the feature from this ResNet and pass it to this SVM classifier. Now for this you can perform this, you can write this code. Reducing the dimension, because SVM, the main limitation of SVM is that it cannot work with the high dimensional dataset. I have got here with high dimensional. So here it is a high dimensional dataset, so I am just reducing its size for dimension for PCA. And similarly you can also use PCA. I will describe it in the next session. Till then, hope you enjoy. Okay, bye bye. See you in the next session.
Audio